You are about to experience the competition between the BJT and the MOSFET transistor. So in this video, we are going to compare both transistors on how they behave, where they are needed most and where they are applied. Understanding the difference between these two is very crucial as an electronic enthusiast. You're also going to learn that bipolar are indeed workaholics and the MOSFET tend to slug off. So before we start, I would love if you could predict who will come out best before the end of this video. Is it the BJT or the MOSFET? Let me know in the comment section below. So let's ride in. So I will begin with the BJT transistor, also known as the Bipolar Junction Transistor. The three terminals of a BJT is the collector, the base, and the emitter. But in the MOSFET, it's a different case. The collector in the BJT is what is known as the drain in MOSFET. The emitter in the BJT is what is known as the source in MOSFET, and while the base in a BJT is seen as the gate in a MOSFET. And the arrangements are not the same. The BJT base is a second pin while the MOSFET gate is the first pin. That's why they seem complicated on diagram for the beginners to use. For the BJT, to turn on the transistor, you need around 0.6 volt to 0.7 volt for the base to turn it on, and it is a current controlled device. But for the MOSFET, it's usually 2 volts at its gate and it's a voltage controlled device. Here is a simple LED control switch schematic diagram using the bipolar and the MOSFET. We will compare the difference in their switching response. Let's apply this circuit, but before I go on, let me explain something to you. As you can see, there is no current drop resistor for my LED, which I was supposed to add during the drawing of this schematic and also at the gate of the MOSFET. This is because I am using a 3 volt supply and my LED is a white color, and the voltage drop for a white LED is around 3 volt. Maybe if you're using a red LED, yellow LED, or any color, make sure to check for their voltage drop to know which resistor to use. Like for a red and yellow LED, the voltage drop is around 1.8 to 2 volt, which requires, if you're using a 3 volt as I am, a 50 ohms resistor. This will help prevent your LED from getting burnt. And why I never mind adding a resistor at my MOSFET gate is because the voltage required or threshold voltage for my MOSFET gate is 2 volt and my supply is 3 volt. So that was still fine, but I suggest you add a resistor of around 100 ohms because sometimes it's the right way of doing things. The first switch will trigger the BJT and the second will trigger the MOSFET. And at this point, I have my 3 volt supply input. When the BJT is closed and released, we can see how fast this responds to switching. But for the MOSFET, when I first press the switch and release my finger off, we can see a little delay before it goes off, like I added a physical capacitor to hold the charge. But for the BJT, it's nothing like that. So why is that? This is why MOSFET seems complicated to beginners, and with this, BJT is preferable for start in learning electronics. The result of the behavior of our MOSFET comes from the physical structure of the MOSFET, which causes a behavior of a parasitic capacitor, meaning they are not wanted but inevitable. These values of capacitor are very small in range of picofarad. So to solve our problem, we just need to add a resistor of around 1K between the gate and the source, and this should help. And now you can see how it works perfectly. But this capacitor plays a crucial role in the operation and performance of the device, particularly in high frequency applications and high speed application. And that is why MOSFETs are preferable for inverters application and also used for CMOS chips, also known as complementary metal oxide semiconductor. And this is where MOSFET have it all. And BJT are used for TTL, also known as transistor to transistor logic. And the TTL has higher power consumption, but CMOS has low power consumption. TTL has low density, but the CMOS has higher density. But TTL are more rugged and durable, but CMOS are easily destroyed. That is with electrostatic charge. That is why you need to be careful when handling these devices. But when it comes to powering this transistor, MOSFET requires no ballast resistor, but the bipolar does require a ballast resistor because the bipolar, if powered without the resistor, would give more and more of the shared current to the hottest transistor as soon it would be getting little or no help from the partner and would burn out. This because bipolar prevents response to temperature. The hotter it gets, the more current it wants to pass to its leads, which leads to current hogging. BJT are workaholics, while MOSFET tends to slug off. BJT operates with a continuous flow of current, requires a constant input voltage to maintain operation, and can handle current and power dissipation. The MOSFETs operate with a gate voltage that can be switched on and off, allowing them to take breaks. They also have a very high input impedance, making them sensitive to voltage but not current, and they can also enter a low power standby mode when not in use. So in summary, the bipolar is a current controlled device, while the MOSFET is a voltage controlled device. The temperature coefficient of a bipolar is negative, while the temperature coefficient of a MOSFET is positive. The base is controlled by current, but while the MOSFET gate is controlled by voltage. The BJT are cheap, while the MOSFETs are expensive. The bipolar, it has low current gain, and while the MOSFET, it has high current gain. The bipolar has low input impedance, and while the MOSFET has high input impedance. The bipolar has low switching speed, and while the MOSFET has high switching speed. The bipolar has low frequency response, and while the MOSFET has high frequency response. The bipolar has a voltage drop across VCE is about 200 mV, and while the MOSFET voltage drop across the VDS is about 20 mV. The bipolar base requires 0.7 volts, and while the MOSFET gate requires 2 volts. The bipolar, it is used for low power applications, and while the MOSFET, it is used for high current applications. So I will consider MOSFETs better in my case because I love the strength these still possess. But all just have their strengths and weakness. So which do you think is your best? Let me know in the comment section below, and don't forget to subscribe, like and share this video to help other beginners out there become smart with electronics.